At this point in the course, I've shown you some of the basic building blocks of an ASP.NET 5 web application by simply responding to a request with some simple logic and static files. But all I've really demonstrated so far is the core platform that ASP.NET provides. Sure, we could build a web application by defining series of middleware endpoints, but there is an easier way. What we need is a framework that we can build on top of that takes care of all the mundane plumbing code for us and lets us focus on writing our application logic instead. And in my experience, the ASP.NET MVC framework is a great choice. What is ASP.NET MVC? Well, to answer that, I'm going to take a step back and define the MVC, or Model View Controller pattern, that it was named after. The Model View Controller pattern is a user interface design pattern that promotes separation of concerns across multiple application layers. In other words, instead of putting all the view logic, application logic, and data access logic for an application in a single place, MVC promotes separating each of them into specific classes, each with a small, specific set of responsibilities. Separation of concerns is a powerful principle that is frequently used in the design of platforms and frameworks. For example, web pages in the early days of the web contain markup that combine the layout, style, and even data all in the same document. Over the years, standards based on separation of concerns emerged, and what was once one document is now split into three parts: an HTML document, which mainly focuses on the structure of content, one or more CSS style sheets that define the style of the document, and JavaScript to attach behaviors to the document. In the context of the Model View Controller pattern, separation of concerns is used to divide the application into three key components: models, views, and controllers. The view is exactly what it sounds like. It's the part of the application that the user sees and interacts with. In a web application, the view is everything that gets rendered down to the browser: HTML, CSS, and JavaScript. The view's single responsibility is to deliver a high-quality, good-looking user experience to the user, and nothing else. In other words, your goal should be to make the view as pretty and as dumb as possible, relying on the controllers and models to take care of all the smarts of the application and displaying the result. This diagram shows a dotted line from the view to the controller, indicating that the view may actually call back to the controller in order to execute logic that's outside of the view's responsibilities. Be careful here though. It's always tempting to make the view more intelligent than it should be, but you'll want to avoid that at all costs, as it typically results in application code that is more difficult to change and maintain. You'll know you've done it right when you can completely throw away your view and start from scratch with relatively little effort, because the real logic of the application is defined elsewhere, distributed between the controllers and the models. Controllers are the traffic cop of your application, controlling application workflow as the user interacts with the view. For example, I'll soon be showing you how to create a view that accepts the text for a new blog post and displays a button to create that new blog post in the system. When you click on that button, the view will tell the controller about the text that the user has entered, but after that, it's up to the controller to determine to react, perhaps by first executing some validation logic. If the validation exceeds, the controller will then call the data access component to save the blog post. But if the validation or the data access component fails, the controller will choose the appropriate view to display to the user, depending on the error that occurred. Notice how the controller spends its entire life orchestrating interactions between components. This is important, and one of the biggest mistakes a lot of developers make is making the controller too smart by defining application logic rather than orchestration logic. It's best to put all the application logic into the model and let it do the heavy lifting. The term model has come to mean many different things over the years. Perhaps the most popular definition refers to the data structures that are used throughout your application. And while the model certainly does define data structures, it's also much more than that. In the MVC pattern, the model is the heart of the application. It's where all of your business logic lives. Logic such as business processes, validation rules, or even the logic of integrating with other systems. MVC applications with good separation of concerns will contain a model layer that is completely isolated from the platform or environment that it's operating under. In other words, though I'm defining the term model in the context of an ASP.NET web application, If I'm following a strict separation of concerns, I could actually use this same exact model in a Windows Forms, WPF, or even a console application. Practically speaking, you really don't need to worry about creating a model that could be used anywhere, but as far as separation of concerns and good design goes, it's a very good goal to aspire to. So, if that's the MVC design pattern, what is ASP.NET MVC? Well, ASP.NET MVC is Microsoft's implementation of the MVC design pattern on top of the ASP.NET platform. That is, it's a framework that is built on top of those core building blocks that I showed earlier in the course that helps you create a web application consisting of models, views, and controllers with a strong separation of concerns. In this course, I'm going to be talking about the 6th version of ASP.NET MVC. Don't be fooled by the version number, however. This version of the ASP.NET MVC framework, like ASP.NET itself, has been rewritten from the ground up. If you're at all familiar with previous versions of the framework, however, don't be too concerned. You may have to learn a new API, but it should come easy since the concepts are exactly the same. The term that Microsoft folks like to use is concept compatible. For example, if you were used to there being a context property on your controller class, that hasn't changed. There still will be a property named context that represents the context of the current request. However, it's a completely different type than it used to be. These changes definitely take some getting used to, but after a little while, many folks who were familiar with the previous versions of ASP.NET MVC do find working with this new version second nature again. Now that I've got all those high-level concepts out of the way, let's get back to the good stuff. Head on over to the next video in which I'll show you how to add the ASP.NET MVC framework to your application and start implementing a loosely coupled application. In the previous video, I introduced you to the concepts of the Model View Controller software design pattern. In this video, I'll show you how to start working with Microsoft's implementation of the Model View Controller pattern, ASP.NET MVC. We begin by adding the ASP.NET MVC library to our application. To do this, simply add a reference to the library in our project.json file. Search for microsoft.aspnet.mvc. Once you've added it, save the file and switch to the Startup class, where we will register the ASP.NET MVC middleware. To register the middleware, place the cursor above the Use Static Files middleware registration we made previously and type app.useMVC. This call also accepts an optional parameter of a configuration function, in which you can define the route patterns that ASP.NET MVC middleware should be listening to. It looks like this. I'll get into the specifics of routing in a later video, but all you really need to know right now is that this string represents the URL to be matched, and each of these placeholders defines a section of the URL and gives it a name. For example, if we navigated to admin/users/1, that would map to the admin controller, the user's action on that controller, and the ID of 1. Notice that I've also used the equals syntax to provide default values for the controller and action placeholders, which means that they'll always have a value even if they don't have a matching value on the URL string. In other words, if I simply navigate to the root of my site, /ASP.NET MVC will map that to the home controller and the index action anyway. The question mark on the third parameter ID indicates that it's completely optional, and if the URL doesn't supply a value for this parameter, then it will just be null. With all of this, I can now run the site and see what happens. The site is throwing an error because it's not yet been fully configured. In other words, just registering the middleware with the useMVC function was not enough. As you can kind of tell from this error message, this piece of middleware also expects service information, which refers to the fact that it uses dependency injection. In other words, it relies on other services, and those services also need to be registered and configured separately. Luckily, the framework gives us a handy method to call, which will configure those services for us using the default settings. To run this method, jump up to the Configure Services method and add this line. Now that we have the middleware registered and its services configured, let's run the site again and see what happens. We're seeing our static HTML page again, which actually means that what we did is working. It means that the ASP.NET MVC middleware is configured, but it didn't have any controllers registered to handle the request, so it just let the request pass on through to the static file middleware, which offered up our index.html page. Clearly, there's another step we need to begin responding to requests via ASP.NET MVC. Feel free to move on to the next video, where I'll show you how to add logic to that request handling and actually do something useful with this framework. In the previous video, I showed you how to add the ASP.NET MVC middleware to your application. In this video, I'm going to show you how to process requests with ASP.NET MVC by adding controllers to the mix. As I mentioned a few videos back, controllers are the traffic cop of your MVC application. They're responsible for receiving the request and figuring out what to do with it. In an ASP.NET MVC application, controllers are nothing more than classes. So, in order to create a new controller, all you've got to do is add a new class to your application. Though ASP.NET MVC will find controller classes regardless of where they live in your project, the standard convention, for the sake of keeping your project organized, is to put all of your controller classes in a folder named controllers. So before we add our first controller class, let's first add that folder to our project. Just right-click on the project and choose Add New Folder. Then name the new folder Controllers. Now, with that folder in place, let's add our new controller class. To do this, right-click on the controllers folder that we just created and select Add New Item MVC Controller Class. Then just accept the default name of Home Controller and hit Add to add it to the project. Notice how Visual Studio automatically defines a method in this new controller class named Index. This method is called an action, and it's where you're going to define all of your controller logic that gets called when it's time to process requests. In ASP.NET MVC, controllers are nothing more than containers for actions, and in fact, every public method in a controller class is an action. Visual Studio has generated some default code for us, but this code is actually a little more advanced than I want to cover right now, so I'm going to change it to a very simple method, a method that takes no parameters and simply returns a hard-coded string, hello ASP.NET MVC. If I save this file and start my application and then navigate to the root of the site, I see that the hard-coded string is returned back to me. If you're following along and you see the index.html page from last time, your browser is probably giving you the cached result. Just try refreshing the browser or restarting the application until you see the hard-coded text. Now, if I try navigating to other URLs in my site, I get 404 errors indicating that ASP.NET just doesn't know how to handle those requests. But if I navigate to /home or /home/index, those URLs do respond with the hello text. Why is ASP.NET MVC responding in this way? To answer that, we'll have to go back to our startup class where we originally registered the ASP.NET MVC middleware. When we registered the ASP.NET MVC middleware, we provided ASP.NET MVC with a route, a pattern that mapped URLs to controller and action placeholders. And it's this route that ASP.NET MVC is using to determine which controller and action to execute. Once it maps those parts of the URL to those placeholders, it tries to find the controller and action that match those placeholders. This is where the name of the controller class becomes significant. By default, ASP.NET MVC follows the convention that all controller classes need to end with the suffix controller. So, when it starts up, ASP.NET MVC looks through all your classes, finds the classes whose names end with controller, strips off that suffix, and uses the rest of the name to match against the controller placeholder coming from the URL. Then, it finds all of the public methods in that controller class and registers them as potential actions on that controller. The end result of all of this is that when I navigate to a URL such as /home/index, ASP.NET finds the class named HomeController and the method on that class named Index, and then executes it. ASP.NET MVC also allows me to register default values for each of the placeholders in the route using this equals syntax that you can see in the route that I defined in the previous video. ASP.NET also allows me to indicate that parts of the URL pattern are completely optional as well using this question mark syntax. So, this URL pattern says, look for a URL that follows the pattern controller/action/ID. But if you're missing that third part of the URL, that's okay. If you're missing the second part of the URL, the part that defines the action, then just default it to index. If you're also missing the first part of the URL, the part that defines the controller name, then default that to home. The end result, due to these default values, there are 3 ways that I can get to the index action on the home controller: /home/index, /home, or just simply /. In this video, I showed you how to handle web requests in ASP.NET MVC by creating controllers. In the next video, I'll show you how to pass data to your controller actions through simple method parameters. In the previous video, I showed you how to create controllers and controller actions to handle web requests using the ASP.NET MVC framework. One great thing about ASP.NET MVC controller actions is that they're really just methods. And by that, I mean that you can pass data into them. You just go ahead and define a parameter on the method, and ASP.NET MVC will automatically populate that parameter. For instance, using the value of the ID placeholder when it's available. To demonstrate, I'll add another action to this controller by simply defining a new method named echo. I'll have this new method accept a string parameter named ID, and it'll simply return the value of the parameter right back to the user. Now, the name of this ID parameter is very important. It must match the name of the ID placeholder that I've defined in the URL route in order for it to get populated from that value in the URL. And since it does, I can now run my site and navigate to /home/echo/1 and see the value 1 echoed back to me. Likewise, if I go to /home/echo/hello, I see the value hello echoed back to me. The same approach works with just about any type. For instance, if I change the type of the ID parameter to int and then change the return parameter to int as well, I can navigate to the /home/echo/hello URL again and see that it returns 0 because hello is not a valid integer value. So ASP.NET MVC just returns the default integer value 0. However, if I then navigate to /home/echo/123, I see the value 123 returned. There's only so much you can do with accepting and returning primitive values, however. More often than not, you're going to want to respond to a web request by rendering HTML back to the browser. Head on to the next video where I'll show you how to render HTML using Razor views. In the previous few videos, I showed you how to create controller actions that respond to web requests with hard-coded values. However, more often than not, you're going to want to respond to a web request by rendering HTML back to the browser rather than raw text. In this video, I'm going to show you how to render HTML in the browser by creating dynamic ASP.NET MVC views using the Razor syntax. Since returning an HTML view back to the user is pretty much the most common task that an ASP.NET MVC controller action does, the ASP.NET team pre-populates every new controller class with this code. In the last video, I deleted that generated code to demonstrate how controller actions respond to requests. But now that I want to return an HTML view, let me revert back to that original code and see what happens. Now when I run the application and navigate to the root URL, I get an error. Our controller action ran and told ASP.NET MVC to render the view with the same name as the controller action, index. However, ASP.NET MVC can't find a view by that name, and it's tried really hard. It's looked in all these different places. Notice the places that ASP.NET MVC says that it's looking for the view. First, there's /views/home/index.cshtml, and then there's /views/shared/index.cshtml. In other words, it's looking for a .cshtml file with the same name as the action that was called, and it's looking for it in a couple of different folders. The first folder it looks for is a folder with the same name as the controller that is handling the request. In other words, home. Using this convention, we can put all of the views for our home controller into one folder so they're easy for us to find and work with. Next is the shared folder. This is a folder where you can put all of the views that are used across multiple controllers in your application. I'll show you how to use both of these folders, but let's start with the home folder first. Since we have no views folder at all in our project yet, the first thing we need to do is create that. So let's just right-click on the project and choose Add New Folder and name it Views. Then in that Views folder, we can add another folder named Home. Now that we've got the home folder for our views, let's create the index.cshtml view that the ASP.NET MVC was looking for. The CS_HTML extension indicates that the view is defined in the Razor syntax, a syntax that lets you combine HTML and C# code all in one file. That means that we can start by simply moving our existing .html file from our www root folder into this new folder and just renaming it to the .CS_HTML file extension. And that's it. Since HTML is perfectly valid Razor syntax, we don't have to change anything else in the file to make it work. Now we'll just go back to the browser and refresh our page. Instead of that error message, we now see our wonderful homepage again, only this time it's not the static .html file, but a Razor view rendered by our controller action. That's great that we're able to display that single view, but what happens when we want to add another page to our site and still be able to reuse the same HTML layout? In other words, the header and the footer, etc. The short answer is Razor layouts. Head on to the next video where I'll explain what a Razor layout is and how to add one to your site. In the previous video, I showed you how to respond to web requests with HTML markup using the Razor view syntax. When we left off, however, I pointed out that if we only used the approach I showed, which was to render the full page in every view, we wouldn't be able to define a common layout of header, footer, etc. that could be shared throughout our whole site. Sure, we could make a copy of the page and reuse the layout, but that would be really painful when it came time to change those common elements across all pages in the site. Luckily, ASP.NET MVC allows us to define special Razor pages whose sole purpose is to define this common layout and render content from individual pages inside this layout content. These types of Razor pages are referred to as layouts, and they are a great candidate to live in that shared views folder that we saw ASP.NET MVC looking for earlier. To demonstrate how they work, let's create the new shared folder under the views folder and then make a copy of our index.cshtml page into this new shared folder and rename it _layout.cshtml in the process. Now note that there's nothing special about the underscore or the layout in the file name. Those are just naming standards that a lot of people use to indicate that this file is a layout and not a full page. Now open up the newly renamed layout file and replace the main content section with a little snippet of code @renderBody. This is a C# method call that tells Razor to take the body of the view that has been rendered and put it at this location in the layout. With the layout in place, we can go back to our index.cshtml page and modify it to take advantage of this new shared layout. To do that, simply add the following lines to the top of the index.cshtml file. These lines are more C# code that is setting the layout property of the view to tell ASP.NET MVC that this view should be wrapped in a layout named _layout. How does ASP.NET MVC find that layout? You guessed it, the file named _layout.cshtml in the shared views folder. With these couple of lines in place, we can then remove everything but the main section of content in this view. Now when we refresh the page again, it looks exactly the same. Only this time, the main content is getting rendered by the index view, and the layout of the page is getting rendered from the layout view. Now that I've shown you how to render a basic Razor view, head on to the next video where I get more advanced and show you how you can use even more C# code to render more dynamic views. In the previous video, I showed you how to create dynamic views by creating HTML files and adding a little bit of C# code to turn them into Razor. In this video, I'll take that a step further to show some of the cool things you can do when you mix HTML and C# code to produce dynamic HTML output using Razor. Currently, the index action displays the last couple of blog posts, which is nice for our homepage, but we also want people to be able to navigate directly to a single post as well. In order to allow that, let's create a new controller action on the home controller named Post. This new action should return a view just like the index action. In fact, we can just copy the index action and rename it to Post. However, unlike the index action, we'll also need the ability to refer to a specific post by ID. So let's add an ID parameter to the post method, just like I demonstrated a few videos back with the parameters on the echo action. This ID parameter should be a long, since that's what our post ID will be when we create it in just a minute. Then to create the view, Let's make a copy of the index.cshtml file, rename it to post.cshtml, and then remove all but one post. Then let's navigate to our new action in the browser just to make sure that it works. We can navigate to /home/post/1. Now, so far we haven't done anything new yet. Now let's have a little bit of fun passing data from the controller to the view. Let's say we want to be able to set the title, the author, the date of the post, and the body of the post as variables in the controller and pass that info to be rendered into the view. The easiest way to do this is with the viewBag property, a dynamic object property that lives on both the view and the controller. Thus, whenever we set a value on this object in the controller, it will also be available in the view. And since it's dynamic, we can just access it as though the property already exists, just like this. Then we can go into the view and read these properties from the viewBag and render them right in the page in the appropriate places. To do this, we simply use the @ symbol to tell Razor to render the code that follows the @ symbol. Once the code is done and we're back to HTML, Razor stops rendering and continues rendering the HTML normally. Now when we refresh the page, we can see the data that we've set in the controller getting passed into the view and rendered in the browser. See, there's a problem with this approach though. The viewBag property is a dynamic object, which is actually a double-edged sword. On the one hand, it's really easy to work with since you don't have to worry about types. On the other hand though, you don't have any type information, so Razor can't give you any IntelliSense, nor can it protect you from any type conflicts, such as when you expect that the value of a property is a string when it's really an integer, and then you try to execute a string method on it, which then fails. Now check out the next video where I'll show you how to pass a strongly typed data model from your controller to your view in order to get that full IntelliSense and type checking right inside your Razor file. In the previous video, I showed you how to pass data from your controller to your view, but I did it with the dynamic viewBag property. And while the viewBag property is a convenient way to pass data around, its dynamic nature often leaves a lot to be desired. In this video, I'm going to show you an alternative to the dynamic viewBag approach, passing a strongly typed model into your view. That is, not only passing an object that represents your model, but also define what type that model should be so you get full IntelliSense and static type checking right there in your view. In order to create a strongly typed view, we first need to create a type that we can use as our model type. Before we do that, let's create a models folder in the root of the application to hold all of our model classes in. Then we can create a brand new class, just a simple type name post with a couple of properties in it: title, posted date, author, and body, etc. Once we have this, we can refactor our viewBag property setting approach and instead set those properties on an instance of this new post class. Then we have to pass that instance right into the view as a parameter to the view method that we're calling at the end of our controller action. Next, let's jump to the view so we can start consuming this model. The first thing we're going to have to do is tell Razor what type of model we're passing in. We can do this by adding the following line to the beginning of our file. Then we can replace all of those existing references to the viewBag with references to this new strongly typed model, complete with full IntelliSense and static type checking. When we're done, we'll go ahead and refresh the page to make sure it all still works. Once again, we're greeted with the same exact view as before because we didn't actually change the output. We just improved the way that we were passing data from the controller to the view. So far in the course, I've shown you how to send data to the user, but now let's switch things around a little bit at this point. Check out the next few videos where I'll show you not just how to render HTML in a browser, but also accept user input through form posts. In the previous video, I showed you how to improve Razor views by turning them into strongly typed views. In this video, I'm going to go one step further and show you how you can reuse sections of Razor markup throughout multiple views using the partial view technique. Now, put simply, partial views allow you to take chunks of your views and put them in their own separate files, and then stitch them back together again to create full views. This might sound a little silly at first, breaking your view into multiple pieces just to put it right back together again, but there are several advantages to this approach. First and foremost, your view becomes more manageable simply because it is smaller, therefore easier to understand. Frankly, this simplicity is often the only reason you'll need to create a partial view, but If that's not enough of a reason, there's a functional reason as well, and that is the ability to reuse the same view in multiple places throughout your application. For example, take a look at the homepage of the sample blog application. See how it's showing the most recent couple of blog posts? Well, actually, it's showing a couple of blog posts that I've hard-coded into the view, but in the real application, the homepage would be pulling in the most recent couple of blog posts from the database and rendering them within this view. Now, assuming that I want the blog post markup shown on the homepage to look exactly like the blog post markup shown on the individual post page, I could implement my homepage by copying and pasting the Razor markup from this post view that we just created. Now, that'll work just fine. In fact, that's a perfectly legitimate way of doing it. But if I want to keep them in sync, what I really want to do is create one partial view that both of them can share. To do this, I'll create a new view. Because I want any controller to be able to use this view, I'll actually put it in the shared folder. In fact, to save time, I'll just copy my existing post.cshtml into the share folder and rename it to _post.cshtml. Again, there's nothing special about the underscore in this name. It's just a convention to tell other developers that it's a partial view and to help differentiate it from the full view of the same name that still exists. Then I'll simply remove the layout property. And that is my partial view. In other words, there's nothing inherently different between regular Razor views and partial Razor views other than the way that they are used. Now with that in place, let's go ahead and use it. Let's start by rewriting the original full post.cshtml to take advantage of this new shared view. To do that, I'll remove all of the markup, but I'll leave the line where I'm setting the layout property, so this will continue to render as a full view. Then I'll replace all of that markup with a single line, a call to html.partial, and I'll pass it in the name of the new partial view that I just created. With that in place, I can run my application and view one of my posts to see that it still works. Once again, we have yet another somewhat underwhelming demo where we've moved a bunch of things around and came up with the same result. So let's get to the good part and actually reuse this same view on the home page. And once again, we start by removing the existing hard-coded HTML and replacing it with a call to html.partial. What this will do is render one post, but keep in mind that I actually want the home page to render multiple posts. Since we can write C# code in our Razor views, this is pretty trivial. In writing this chunk of code, I've introduced two things. First, in order to write the for each loop, I have to iterate over something, so I've used the model property. Keep in mind that in order for this to work, I need to specify the model type for this view. Then, in order to run this, I'll need to update my controller to pass a model to this view, which I'll do in a minute. The second thing I've introduced is the fact that the html.partial helper accepts a second property which represents the model for this particular view. In other words, the partial post view references the model property of the post type to render the post data. This worked in the full post view because it already had a model populated with an instance that matched the post type, and the partial helper just copied that model to the partial view, so everything was fine. Now clearly, this won't work on the home page because the type of the model in my home page is a collection of posts, not a single post. To get around this, I create a for each loop and loop over these posts, and then call the partial helper for each instance of a post. That's all the changes I need to make to the view. Now let's jump into the controller and populate the model so that we can run this and see it in action. In my index action, I need to create an array of posts to populate the model that our view expects. Since we haven't wired this controller up to a database yet, I'll keep using the hard-coded data and just copy and paste the code that's currently in my post action and change it just a little bit. Then I'll pass these hard-coded posts into the view. With all of this in place, I should now be able to run my application and see it in action. Now that I've shown you how to create partial views and display hard-coded data, let's shift gears a little bit and head into the next chapter where I'll show you how to create a dynamic site by accepting data from users and storing it in a database to render later on.